Okay, this should be page 17 of the synchronization notes. Let's look at a problem scenario from the solution that I just showed you. Don't know if you've looked at it and tried to figure out what could go wrong with that, but definitely something could. And let's look at the resource allocation graph to illustrate this. And I'm going to draw it kind of like we had the original drawing for the dining philosophers problem. So this will be philosopher 0 here, and to their left is fork 0, and then to their right will be fork 1, and then philosopher 1, and then fork 2, philosopher 2, this will be fork 3, philosopher 3, fork 4, and philosopher 4. So remember, each task or thread is shown as a circle in these resource allocation graphs, and resources or mutexes are shown with boxes. Let's just say that due to a freak of timing, philosopher 0 got as far as acquiring their first mutex. So they got the one on their right, and then there's a context switch, and so philosopher 1 gets as far as acquiring the fork to their right, and there's a context switch, and it goes on. So philosopher 2 gets its first fork before we switch to philosopher 3, which acquires fork 3, and we switch to philosopher 4, which acquires fork 4. And then let's say that, for example, they execute again in the same order. So now philosopher 0 wants to acquire fork 1. I'll do this in green to show that it's waiting on fork 1. So philosopher 0 is going to block because philosopher 1 is holding fork 1. And philosopher 1 wants fork 2, which is not available, so it's going to block. Philosopher 2 wants fork 3, so you can see the cycle going here. And philosopher 4 wants to acquire fork 0. So I'll just add an annotation. So for when you come back later, philosopher 1 has fork 1 is waiting on fork 2. So you've got 5 philosophers, and they are all blocked, and the name for this is deadlock. None of them are ever going to run again, and that's obviously a problem. So to solve this, or to prevent this from happening, what we need to do is remove one of Kaufman's 4 conditions. So we need to remove one of Kaufman's 4 conditions for a deadlock. Getting rid of the mutexes would be hard. There's not an obvious solution to doing that. Maybe getting rid of the hold and wait, somehow changing that might be an option. The one that we're going to tackle first is breaking the circular wait. Another option is preempting resources. I guess you could have philosophers kill each other and take their forks, but that wouldn't be a satisfactory solution. Let's look at the solution. We'll use the handout again.